Hello and welcome to this video for 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 April the 2nd for Algebra 2. And what we're going to talk about today is how you solve equations that have exponential terms in them. We've recently, the last 2 days of class, we've been looking at graphing exponential functions, and today we're going to look at solving exponential equations. Those are equations that have x in the power. Okay, so we're going to be solving equations that have x in the power. Now, before we get there, before we jump into that, I want you to look at what's on the screen at the moment. So this is in the Algebra 2 OneNote folder. It's under Chapter 6, Exponential and Logarithmic Functions. And it's the last page, okay? I know there's lots of stuff that we haven't done yet, but I've just added this, that's why it's in at the bottom. So the last page of Chapter 6 is Table of Exponents. So close the pane on the left hand side and let's look at this table now. So this gives us a quick table for writing down the value of exponents of numbers. And the way you read it is that down the side here, down the left hand side, you have got the base. Okay, so the base comes from this number down the left hand side, and along the top you have the exponents or the powers. Okay, exponents or powers. Okay, so how does this work? Well, for example, let's say you wanted to know 4 to the power of 7. Well, 4 is the base and 7 is the exponent. So on the bases, that's down the side, you'd look up 4, so we're talking about here. And the exponent is 7, so that's here. So 4 to the power of 7, you'd go over to where those two lines coincide, would be 16,384. Okay. Similarly, let's say you wanted to know what, let's say 9 to the power of 3 was. Okay, so 9 is the base, 3 is the exponent, and if you look that up, 9 here is the base, 3 is the exponent, so we're looking down here, so 9 to the power of 3 is 729. Okay, so that gives us a much quicker way of working it out. Remember, 4 to the 7 means 4 by 4 by 4 by 4 by 4 by 4. That's 1, 2, 3, 4, 5, 6. We need one more. 4. Now, if we didn't have the table, we'd have to go through and try and work all this out. Or, of course, you could go to the calculator. But it would take a lot more time, and this one would be 9 times 9 times 9. Not quite as strenuous as the 4 to the power of 7. But that's going to be useful for us. But really, what you should be trying to do as well is you should be trying to learn as many of these as you can. So 1 to any power, regardless of what the power is. If the base is 1, then 1 to the power of anything is always 1. The others that you should know, I would say you should know the 2's, powers of 2, up to, and just know these off by heart if you can. Let's say up to 256. Okay, if any of you are interested in computers, then you'll know that 2 to the power of 8, 2 to the power of 1, all the way through to 2 to the power of 8. Those are very important numbers in computing because bytes are made up of 8 bits, and again, if you know about computers, you'll know what I'm talking about. If you don't know computers, you don't need to worry too much, but certainly if it's something you would study going forward, you definitely would want to know the powers of 2 up to 2 to the power of 8. 3, for powers of 3, you would want to know definitely 3 to the power of 4 and probably 3 to the power of 5 if you can do that. But definitely 3 to the power of 4 you'd want to know. Powers of 4, very useful to know these powers of 4. 4 to the power of 4. Again, if you only know up to 4 to the power of 3, that's not so bad. 5 if you know powers of 5 up to 5 cubed, that would be good. And the rest of them really just the squares, which you probably know already. So just the squares. So what I'm talking about here, the reason I'm doing this is because I want you to try and make an effort to learn these off by heart. Powers of 10 are quite easy. Yeah, the power tells you the number of zeros after the 1. So 10 to the power of 6 will have 1, 2, 3, 4, 5, 6 zeros after the 1. 10 to the power of 8, there'll be 8 zeros after the 1. So powers of 10 are pretty straightforward. Again, it's definitely worth knowing the first 6 up to 1 million. 10 to the power of 6 is 1 million. Okay, so that's sort of a brief introduction of things that you should know. Those are basic math facts that you should be making an effort to learn. If you don't learn them, everything you do afterwards will just be slowed down. It doesn't mean you won't be able to look them up, but it'll slow you down. These are numbers that come up a lot in math. Very useful. Okay, so let's see what we're going to do today. So let's go back here, open up the panes again. We're still in chapter 6, but now we're going to go up here to solving exponential equations. So the second page, solving exponential equations. And what we've got here, solving exponential equations and the compound interest formula. We won't get as far as the compound interest formula in this video. And we may just do the one example, we'll see. Okay. So the way to solve exponential equations is very different from solving equations that we've done in the past. Let's read about the principle of it, what's the basics of it. Well, the principle of solving exponential equations is that all the bases in an equation are written in terms of a single base number. Okay, so you try and write both sides of the equation in such a way that they have the same base. We then make the exponent on one side of the equation equal to that on the other. If we have the same base on each side, then the powers also have to be the same. And that's the key. So you want the bases to be the same so that the powers will be the same. So let's start with this example, 3 to the power of x. Okay, so we have 3 to the power of x equals 9 to the power of 5. Now what we try and do is we look at our bases. We have a base 3 and a base 9. What you want to do is you want to take the bigger base and write it as a power of 3. So we want to write 9, the bigger base, as a power of 3. Okay? Well, hopefully you know that 9 is equal to 3 squared. Okay, 9 is equal to 3 squared. When the numbers get bigger, you might need to use the table that we just looked at. So if we go back to the table of exponents, look up 3. You want to write 9 as a power of 3. So look in the 3 table, or in the 3 row. You want the base to be 3. Find 9, and the power is 2. So this tells you that 9 can be written as 3 squared. Okay, so 9 can be written as 3 squared. That's how we do it. Let's go back now. Well, hopefully numbers like 9 and 3, we know what that is anyway. So what we do now, we're going to replace the 9 with 3 squared. So 3 to the power of x equals, instead of 9, we're going to put 3 to the power of 2. We're going to put it in parentheses. And then we had that 5. Okay, we keep the 5. Okay, so we've replaced the 9 with 3 squared. Now we have the 5 outside. On the left, we still have 3 to the power of x. Now, over on the right-hand side, we have an outside power and an inside power. So we talked about this a long time ago. What do you do with exponents if you have an inside power and an outside power? You multiply them. Okay, so we're going to multiply the 2 times the 5. 2 times 5, which would be 10. Okay, so I'll just assume that we get that. Now, this is where we make a little statement. The bases are the same. So the bases are equal. And this doesn't work until we get the bases to be equal. So that means the powers are also equal. Okay, so the bases are equal, and that means the powers are equal. So that would tell you that x is equal to 10. Now, sometimes we might have to do more work. Let's say this had been x plus 4 instead of just x. If that had been x plus 4, we'd say x plus 4 equals 10, and then we'd have to move the 4 across because we want to end up with x on its own. Now, we get it here very quickly, and so it works out for us. Okay, the next example we'll do will be a little bit more difficult than this one. Okay, but thanks for watching this one. X equals 10 is the answer. Okay, thank you.